How's it going? This video is on multiplying fractions. If we have two fractions, a over b times c over d, multiply the two numerators, a times c, that will be the new numerator, and b times d, that will be the new denominator. Okay, here's our first example. Multiply 6 over 7 times 3 over 10. So that product is 18 over 70. But can we reduce that fraction? Yes, we can. What number goes into both 18 and 70? Well, they're both even. They both have a ones digit of an even number. So that means we could divide both of them by 2. So 9 over 35. Okay. So what we did in this example is we multiplied first and then reduced second. However, it is generally much easier to reduce first before multiplying. So this problem, the way we did it was fine, but what happens is if you just multiply straight across, you can end up with some really large numbers. And then reducing is going to be very difficult. So what we find is that it's easier to reduce first and then multiply. Okay. So now we'll have a better process here. Our first step is to reduce vertically or diagonally. And then second, then we can multiply across. Last time what we did is we multiplied across and then we reduced. This time we're going to reduce first and then multiply. Okay, so what we want to do is find a number that divides evenly into any numerator and any denominator. So remember, we could reduce vertically or diagonally. Let's see, the 9 and 15, right? What number goes into 9 and 15? 3 does. So we're going to divide both the 9 and 15 by 3. So we're not going to write down the 3. We're going to cross out those numbers 9 and 15, and we're going to write above it or below it how many times 3 goes into that number. So how many times does 3 go into 9? 3 times. And how many times does 3 go into 15? 5 times. That's what we do. We cross out the 9 because 3 goes into 3 times, and 3 goes into 15 5 times. Okay. Is there anything else? Is there another number that goes into a numerator and denominator? Now don't forget, vertically or diagonally. So nothing goes into 8 or 11. 8 and 11, I should say. So now we can multiply straight across. That would give us 8 times 3 for the new numerator and 5 times 11 for the new denominator. Okay, so that wasn't so bad. If we were to multiply across, we would have got 72 in the numerator and then 15 times 11, whatever that is, and then we would have had to reduce that number. Okay, let's go on. 12 over 25 times 15 over 16. Might want to pause the video and try to work it out on your own. If not, then let's get started. Find a number that divides evenly into a numerator and a denominator. Let's see, the number 5 will divide evenly into 15 and 25. Won't it? Yeah. How many times does 5 go into 15? 3 times. So you're going to cross out the 15 and put a 5 where the, pardon me, cross out the 15 and put a 3 where the 15 is, above it. Then how many times will 5 go into 25? 5 times. So you're going to cross out the 25, put a 5 there. We'll do the same thing with 12 and 16. 4 will divide evenly into 12 and 16. That's the greatest common factor of 12 and 16. Now, maybe some of you thought, oh, 2 goes into 12 and 16. Well, then you can still divide by 2 a second time. So try to find the largest number that goes into both numbers. So 4 is a number. Divide 4 into 12. Put the results above the 12. Cross out the 12. Divide 4 into 16. Put the result below the 16. Now we can multiply straight across. Okay, you can always rewind. I guess I'm giving away my age. You could always play the video back a little bit there, so you could go through that process again if you're having a hard time. But we're going to do quite a few more examples. Okay, let's do another problem. 26 over 33 times 22 over 39. Okay, so we're going to find a number that divides evenly into the numerator and the denominator. I guess we could start with a 22 and 33. What number divides evenly into 22 and 33? That's right, 11. 11 will divide evenly into 22 and 33. So divide 11 into 22 and 11 into 33. So 11 goes into 22 twice, and 11 goes into 33 3 times. Now, is there a number that goes into 26 and 39? I don't know. If you're like me, you have a hard time thinking about what number goes into these numbers, so you might want to just do the prime factorization, the tree, for 26 and 39. So 26 is 2 times 13. It's even. 26 was an even number, so we know 2 went into it. Then you just have to divide 2 into that number. Now 39, let's see, 3 plus 9 is 12. 3 goes into 12, so 3 will go into it. So divide 3 into 39 and see how many times 3 goes into 39. You'll get 13. Now it's a little easier to see. What number goes into both 26 and 39? 13 does. 13 goes into 26 twice, and 13 goes into 39 3 times. Now we can multiply straight across. So you should get 4/9. So sometimes when the numbers are large, finding the prime factorization is really helpful. If the numbers are small, it's easier to do in your head. But when you get large numbers, the prime factorization is what really helps us out. So a lot of people don't want to do the prime factorization, and that's okay if you're only going to get small numbers. But are you guaranteed to only get small numbers on a test or in homework? No. So we need to learn the prime factorization and use it so that we're able to multiply all types of fractions, not just the small numbers, but all of them. Okay, so here is a prime factorization method for multiplying fractions. And actually, many students prefer this method because it's more procedural. You don't have to be thinking, what number divides evenly into these two numbers. This is more of a process. Okay, so here are steps. Rewrite each fraction using the prime factorizations for each number. So if you watched the previous video of simplifying fractions, you're still doing the same thing. You're finding the prime factorization and rewriting the numerator and denominator with its prime factorization. Okay, then we could reduce the common factors. That is, line out one number on top with one number with the same number on the bottom. And you could reduce vertically and diagonally. So you could cross out numbers diagonally this time. And then our last step is multiply horizontally the remaining factors. If there's only one number, then that's the numerator or denominator. Okay, so you might want to pause and write down the steps, and then we'll start an example. Okay, let's move on. Now notice the directions say simplify. It could say simplify or multiply. Just in general, we'll say simplify, so we could put any kind of problem there, and it's assumed to be a multiplication problem because of the symbol in between. Okay, so these are large numbers. And you can even use a combination of cross-canceling, but let's just go ahead and use the prime factorization method. Okay, so we're going to find the prime factorization of each number. So 51 and 21. Let's start with the two numerators. Let's see, 51. And again, you might want to pause and work this out on your own. And then click on play when you're ready. So 51, let's see, 5 plus 1 is 6. 3 goes into 6. So we could divide this by 3. So divide 3 into 51. Should get 17. And then 3 times 7 would be 21. Now the two denominators, 70 and 85. Let's see, 70 is 7 times 10. 7 is prime, 10 is 2 times 5. And that's it. 85 is, let's see, it ends in a 5, so that means we would start with 5. And then 5 goes into there 17 times. And then I just like to rewrite it in a row format, so I have less of a chance of making a mistake. Okay, so now what we're going to do is rewrite each numerator and denominator with its prime factorization. So in place of the 51, you're going to replace that with 3 times 17. In place of the 21, 3 times 7. In place of the 70, 2 times 5 times 7. And in place of the 85, 5 times 17. So now if you see the same number on top with the same number on the bottom, you can line out those numbers. So let's see, what do we see? We can line out a 17 on top with a 17 on the bottom, and a 7 on top with a 7 on the bottom. So there go the 17s and the 7. 7 on top with a 7 on the bottom. And it looks like that's it. We can't cancel the 3's because they're both horizontally. One has to be on the top and one has to be on the bottom. Same thing with the 5's. There's two 5's, but they're both on the bottom. So now we can multiply the remaining factors, multiply across. 3 times 3, that'll give us 9, and then 2 times 5 times 5. Let's see, that's 10. 10 times 5 is 50. Okay, it's a little bit of work, but I'm sure you know now that math is a little bit of work. So just find the prime factorization, replace each number with its prime factorization, line out the same number on top with the same number on the bottom, Multiply across and you got your answer. Okay. I know it's a little bit of work, but sometimes with these kind of large numbers, it's definitely necessary. I mean, think about it. Who would have thought that 17 goes into both 51 and 85? Well, maybe me. Okay. But most people won't. Most people are not going to say, oh, 17 goes into those two numbers. So that's why we need to do this process. Alright, let's do another example. This one's not too bad. You might want to, if you saw this problem, you might want to do the cross-canceling method. We're going to go ahead and still do the prime factorization just so that we get a better handle of it. Okay. Again, you might want to pause, work out each of the prime factorizations, replace each numerator and denominator with its prime factorization, and then line out the same factor on top with the same factor on the bottom, and multiply across. Okay, let's work on the numerators. 9 is 3 times 3. 35. 5 times 7. Not too bad. 42. I used 2 times 21, but you could use 6 times 7. And then 21 is 3 times 7. 40. 4 times 10. You might want to use 5 times 8. Doesn't matter. 4 is 2 times 2, and 10 is 2 times 5. Then I like to rewrite each of them. Again, just to decrease my chance of making a mistake. Now I'm going to replace each number with its prime factorization. So in place of 9, 3 times 3. In place of 35, 5 times 7. In place of 42, 2 times 3 times 7. In place of 40, 2 times 2 times 2 times 5. Now we can start reducing. See, there's a 3 on top with a 3 on the bottom. It doesn't matter the order, but remember, it's got to be one number on top with one number on the bottom. What else? Let's see, I see a 7 on top with a 7 on the bottom and a 5 on top with a 5 on the bottom. So there go the 7s, and there go the 5s. Looks like that's it. Only a 3 left on top. And let's see what's that on the bottom. 2 times 2, 4. 4 times 2 is 8. 8 times 2, 16. So 3 over 16. Okay, let's do another example. Multiplying a fraction by a whole number. When multiplying a fraction and a whole number, write the whole number as a fraction by writing it with a denominator of 1. So just put a 1, any whole number, and now you've written it in fraction form. You see a 5, write it as 5 over 1. 18, 18 over 1. Okay, here's your next example. And this time, there's numbers are pretty small, so I wouldn't do the prime factorization. Let's go ahead and do the cross-canceling. Unless you really like it, you can. It's your choice. So first step is write a 1 under the whole number. And now we could reduce and multiply. Again, I'm just going to see if I can find a number that goes into a numerator and denominator. Let's see, 9 and 18. What number goes into 9 and 18? 9, the smallest number that's there actually. 3 would be too small. 9 is actually the largest number. So 9 goes into 18 twice and into 9 once. Now we can multiply across. And any number over 1 is written as the same number. So don't stop at 4 over 1. It's equal to 4. Any number divided by 1 is itself. So that's the most simplified form of 4. Okay, multiplying mixed numbers. Remember, a mixed number is a whole number with a proper fraction, like 3 2/5. Our procedure is convert all mixed numbers to improper fractions. Second, reduce and multiply. Third, convert answer to a mixed number if necessary. Okay, so that last step, if necessary, it depends on the directions. Many times they will say change any improper fractions to mixed numbers for an answer. Especially if it's a word problem. Let's say the answer is 9 over 2, 9 halves. And the question is, how far does it take to drive somewhere? Well, saying 9 halves for an answer, that doesn't really make sense, does it? But if you said 4 1/2, now does it make sense? Yeah, so if you said, oh, it takes 9 halves hours to get there, they'd say, what? But if you say 4 1/2 hours, okay, that's a little bit of a drive. Okay, so let's see. Again, the directions may state do not leave answers as improper fractions. What they're saying is you cannot leave it improper. You got to change it to a mixed number if you get an improper fraction. If you get a proper fraction or a whole number, then just leave it the way it is. So if your answer is improper, then you must change it to a mixed number. And also, if the answer is to a word problem, then the answer should be changed to a mixed number. Okay, let's do one. 3 1/3 times 2 1/4. And in the directions it says do not leave an improper fraction for an answer. So our first step, rewrite any mixed numbers as improper fractions. So remember, multiply and divide. 3 times 3 is 9. 9 plus 1 is 10, so it's 10 over 3. Do the same thing with the second fraction. 8. 8 plus 1 is 9, so 9 over 4. We have 10/3 times 9 over 4. Now we can reduce and multiply. Let's see. 3 and 9. 3 goes into 3 one time, 3 goes into 9 3 times, and then the 4 and 10, you can reduce those by 2. So 3 goes into 3 once, 3 goes into 9 3 times, and then 2 goes into 4 twice, and 2 goes into 10 5 times. Now we can multiply straight across. 15 over 2. So that's the answer, except that it said do not leave an improper fraction for an answer, and that is an improper fraction. So we're going to have to divide 2 into 15. 2 goes into 15 7 times with a remainder of 1. So it's 7 1/2. Okay, let's do another problem. You might want to pause, work this out on your own. Think you could do it? Okay. Let's change the mixed numbers to improper fractions. Should get 22 over 5 and 12 over 11. 1 times 11 is 11, plus 1 is 12. 12 over 11, yeah. And 4 times 5 is 20. 20 plus 2 is 22. 22 over 5, yep. Any reducing here? No, right? What's any reducing? Oh, no, sorry. 11 and 22. 11 goes into 11 once. Well, let me just say that. Let me backtrack a little bit. Sometimes you can't reduce, so don't expect that every problem has to reduce. In this one it does. 11 goes into 11 once, and 11 goes into 22 twice. Now that's it. So now I can multiply across. And then again, change that improper fraction to a mixed number. 4 and 4/5. I almost missed that 11 and 22, huh? Okay, let's keep going. Multiplying with more than two fractions or mixed numbers. So if we have more than two, now you could remember you could reduce vertically and diagonally, and you could skip fractions. You could reduce. They don't have to be right next to each other for you to be able to reduce. It's all multiplication. Okay, step one. Same as before. Convert all mixed numbers to improper fractions. 2a. Reduce any numerator with any denominator. That's a cross-canceling method. Or 2b. Or reduce using the prime factorization method. Depends on the numbers, right? You have large numbers, use a prime factorization. And then 3, multiply the remaining factors. And 4, convert answer to a mixed number if necessary. So if the directions say so, then we will. Okay. First thing is we're going to change the improper fraction to a mixed number. There's only one improper fraction in this problem, that last one. So 1 times 5 is 5, plus 3, 8. So that would be 8 over 5. And now we're going to reduce. The numbers are pretty small. I think we can go ahead and use the cross-canceling method. Let's see, I see maybe the 8 and 12 and the 7 and 14. Let's see, 7 divides into 7 and 7 divides into 14. So 7 goes into 7 once. Oh, that should be a 2 right there. And let's see, what about the 8 and 12? 4 divides into both of them, right? 4 goes into 8 twice, and 4 goes into 12 3 times. And now we can multiply across. This is not right. Oh, oops, sorry about that. Now this 2 and this 2, we could still reduce. So you could use those same numbers again. How many times does 2 go into 2? Once. How many times does 2 go into this 2? Once. So then you multiply across and you'll get 11. And the denominator, 3 times 5, 15. Sorry about that. I hope I didn't have to make any adjustments, but I guess I was kind of ready with the red pen here on the arrow in case I didn't make mistakes, and they happen. So 7 goes into 7 once, and 7 goes into 14 twice, and I had a 7 there. Okay, so our answer is 11 over 15. Okay, let's go on to the next problem. Okay, here we have some larger numbers. You know, you could see how easy it was to make a mistake with the cross canceling. I think this one we should just do the prime factorization. There's less chance of a mistake. Okay, so let's write down all our numbers. Let's see, 34. And you might want to pause to work these out. 2 times 17. 24 is 4 times 6, and 4 is 2 times 2, 6 is 2 times 3, and 26 is 2 times 13. Now the denominators. 39 is 3 times 13. 85, let's see, 5 goes into that one. 17. 60 is 6 times 10, and then we'd factor the 6 and 10. Okay, you might want to pause, probably going too fast right there. Okay, so replace each number with its prime factorization. So in place of the 34, it's 2 times 17. 24 is 2 times 2 times 2 times 3. 26 is 2 times 13. 39, 3 times 13. 85, 5 times 17. 60, 2 times 2 times 3 times 5. Let's see, we can cancel out a 2 on top with a 2 on the bottom. We can cancel out another 2 on top with another 2 on the bottom. You know, if you chose a different 2, it doesn't matter which 2 you chose. You could have chosen the 2 from the first fraction and the 2 from the last fraction. But don't forget, vertically also, you could reduce vertically. Let's see what else. A 3 on top with a 3 on the bottom. Is that it? Oh, 17. 17 on, oh, a 13. First let's do the 13. 13 on top with a 13 on the bottom. And then the 17 on top with the 17 on the bottom. I think that's it. Yep. So we should get 8 on top, multiply 2 times 2 times 2 is 8. And 5 times 3 times 5 is 75. Okay, let's go to another example. Product. To find the product of two numbers, rewrite the numbers in the same order as presented in the sentence and place a multiplication sign in between. I had fixed this. I don't know why the text came out a little bit off. Okay, place a multiplication sign between them, and then perform the necessary steps of multiplication with fractions and mixed numbers. This number should be right after the mixed numbers here in the box. Okay, we'll let it go, I guess. So example 12, what is the product of 2 and 2/3 and 18? So the word product means multiplication. All we're going to do is put a multiplication symbol in between those two numbers. And actually, does it matter what order you write the numbers? No, because multiplication is commutative. So the order does not matter in multiplication. But usually we just put it in the same order as presented. Alright, so we have a mixed number. I'll let you work on this and then come back when you're ready to finish it. When you have a mixed number, change it to an improper fraction, and you have a whole number, place a 1 underneath it. I think we'll just do the cross-canceling method this time. 3 and 18 by 3. Then multiply across. So our answer is 48. Okay, let's go on. The word of also translates to multiplication if a fraction precedes it. Actually, if you have a fraction or a percent in front of the word of, 10% of, 15% of, or 5/9 of, then the of means multiplication. Alright, so we're just going to put 5/9 times 360 over 1. Now, the 360 is a large number, but I think it's still easier to cross-cancel in this problem because 9 will actually go into 360 evenly. There's a divisibility test for the number 9, and that's if you add the digits up. If 9 goes into it, then 9 will go into that number. So 3 plus 6 plus 0 is 9, and 9 goes into 9, so 9 will actually go into 360. We'll perform that division on this side, and then you should get 9 goes into 360 40 times. So 5 times 40 is 200. So 5/9 of 360 is 200. Okay, next one. Find the area of a rectangle if the length is 2.5 feet and the width is 1 3/4 feet. And remember the formula for area of a rectangle. Area is length times width. So we simply need to multiply the length and the width. 2 1/4 times 1 3/4. Oops, sorry, 2 1/2 times 1 3/4. Change to improper fractions. And then cross-canceling. No, not this time. So multiply straight across. And then 35/8. It's a word problem, so let's change it to a mixed number. Even though it doesn't say, we need to change that to a mixed number. That would be 4 3/8. 8 goes into 35 4 times. 8 times 4 is 32. So you'll get a remainder of 3. So 4 3/8. And don't forget the feet with the exponent 2, it's read as square feet. So 4 3/8 square feet. Okay, one more. 4/9 of Larry's monthly paycheck goes to his mortgage. If his check is $3,420, how much is his mortgage? You know, one thing I also want to say about word problems is the answer needs to make sense. So if his monthly check is $3,400, his mortgage, can it be more than that? No. It's 4/9. It's 4/9 of it. 4/9 is, close to a half. So we should get an answer of like, 1,400, 1,500, something like that. Just kind of think when you solve a word problem that the answer needs to sound reasonable. So if you get, $12, it sound reasonable for somebody's mortgage? Well, I'd be all over that, right? So a mortgage is usually somewhere between 800 and maybe 3,000, depending on how big the house is, how big the loan is. Well, here's a word problem that says 4/9 of the check. So it's a fraction of 3,420. Well, that's multiplication. So it's 4/9 times 3,420. And then put a 1 underneath the number. Now we don't want to find the prime factorization of 3,420. So you have two choices. You could cross-cancel. I think that's a good idea. Or you could multiply straight across and then divide by the bottom number. That's also a possibility. The answer here is not a fraction because it has to come out to be somebody's mortgage, So the answer is going to be $1,300, something like that. So if you wanted to, you can multiply straight across and then divide by 9. Or let's cross cancel. Let's see, how many times is 9 going to 3420, 3,420. Let's divide that. And you get 380. So 9 goes into 9 once. 9 goes into 3420, 380 times. Now it can multiply straight across. And you'll get 1,520. That sound reasonable for somebody's mortgage? Yeah. 1,500 bucks. Probably a house at about 200 plus thousand, 240,000. It all depends on the interest rates also. Okay, is that it? That was it. So, sorry about that. So I'll see you here for the next video. Have a good one.